Hello, this is Daniel Nolasco, and this is Dynamic Modeling of Wastewater Treatment Plants for Resource Recovery, the UCI Extension Course. And I'm going to be answering some questions on how to move files or how to move data from BioWin to Excel and vice versa. So I'm testing a new recording system using QuickTime, so if there's any problems, please let me know with an email or a message to the course website. But what I'm going to be doing is I'm going to open here from the cabinet. I have a BioWin open. I'm going to open the MLE process. The system generally asks me to save because this system has been saved in a previous version of BioWin. But when I open it up, you should be able to see your familiar modified Lutz-Gettinger process. And if you go into the influent wastewater point and you go, you're going to notice that it's set up in variable. Now, if I go edit data, you're going to see all the files or all the data for flow rate, COD, and all the rest of the parameters. Please notice that the flow is set up in million liters per day. If I wanted to copy it to Excel, which is what I'm going to do in cubic meters per day, you better go and click this button, or else you're going to have to convert it once you are with the data in Excel. So I'm going to stand on the first cell and I'm going to go copy. Now, if I open now Excel, any workbook I'd like to work on, and I click here and I go paste, you will see that I have passed on to Excel the data that were available in BioWin. Now, probably the most interesting thing for you is to pass on data from Excel to BioWin to run a simulation dynamically. I think I've shown this before, but it's worth going again and doing that again. So for this case, I'm going to close and I'm going to cancel what I did here for MLE. I'm going to open instead another layout, an aerobic digester, for example. You can pick any one you want. I'm going to say no to the changes in the current, and an aerobic digester again was saved in the previous version, so I go save, yes, I accept everything, and you're going to notice that here your influent is for steady state. So I'm going to double click on the influent icon. I'm going to go variable. I'm going to open edit data. As you could guess, the data is only the data points that I put for the steady state condition. So now, if I want to pass on data that I have from an existing plant in Excel, which for this exercise, I'm going to assume that is the one that I copied from the previous file. I'm just going to make sure you don't copy the titles because those are already there in BioWin, but I'm just going to copy the data. One thing to keep in mind, that if you want to copy a matrix with several values for different parameters, the parameters will have to be in the order in which they show up on the BioWin input screen for dynamic data. If they're not, you're going to have to either rearrange them or copy column by column where they belong. So in this case, I'm going to go copy. I'm going to go back into BioWin. I'm going to stand on the first cell. I'm going to go paste. And I have entered the values that were in my Excel, which I could assume that are coming from real data from a plant or from any data you have synthesized and you want to test. And I'm going to go close. I'm going to close here, going OK. And now I'm going to have the data ready for simulation in this layout. So I've showed how to pass influent data to Excel and data from an Excel as influent. Now, an interesting thing to see would be how to copy results from Excel, from BioWin onto Excel. So to do this, I'm going to go back to the very simple MLE process. I'm going to say that I do not want to save I'm going to go through the same process. I'll show you how to avoid doing that if you want to. But in this case, I'm interested in looking at passing effluent data or time series of data to Excel. So I'm going to go on to effluent properties, and since there's no properties, physical or operational properties in the effluent, the only properties that show up are what is called monitor items. And here I'm going to mark those parameters that I'm interested in looking at in my Excel spreadsheet. For instance, volatile suspended solids, total suspended solids, total COD, total phosphorus. You click any parameters you want: total kettle nitrogen, nitrate plus nitrite, total nitrogen might be interesting to you, alkalinity, pH. I mean, you pick the values that you're interested in. I'm interested in the flow rate, so I'm going to go here. I'm going to go, since flow rate is a state variable, I'm going to here flow, and I missed, I think, BOD. Oh, here it is, total carbonaceous BOD. I'm going to click on it, and I'm going to go OK. Now, I'm going to tell the system that I want this recorded. What I'm monitoring, I want it recorded on a file. So I'm going to go Project, Database, and I'm going to, Project, Database, and I'm going to go Export to File. And this is going to tell me the data that I'm monitoring, where I want to send it, and in which format. It could be a text format, or which can be imported into Excel, or a comma delimited, a comma separated value type of file, which is the one that I'm going to pick. I'm going to call it, since I have already one that up there that is called test, I'm going to call it one that is lecture UCI test, and I'm going to go save. And this is going to tell me basically all the data that I have selected and I want to be exported to the file. I'm going to close. If there was something missing, I can go back and record. For instance, I could come here and might be interested in mixed liquor suspended solids. So I can go Properties, and here you'll notice that since I'm standing on a reactor, I will have dimensions, I will have operation tabs, but here I have monitor items. And I might be interested in volatile and total suspended solids. And I'm going to go OK. And just in case, I'm going to make sure they show up here. Database, export to file. I'm going to put the CSV file. I'm going to call it there. I'm going to go save. I'm going to say yes. And then I'm going to look back in here and see, well, there you go. Aerobic, volatile suspended solids, aerobic, total suspended solids. The first part of the name is the unit or the icon name. In this case, it was aerobic. And the second part of the name is the name of the variable. So I close this, and now I have to generate the information. And in order to do that, I run the simulation dynamically. Since this is being run already to steady state, and the current values were reasonable, I'm just going to simulate from project start, from current values, dynamically, because that's basically what I want to see data for, and I'm going to run it. I picked a simple MLE because it runs fast. It's going to finish now. I'm going to stop here. I'm going to terminate the simulation. And now I'm going to go back into Excel. I'm going to get out of this file. I'm not interested in saving. I'm not interested in saving anything from the clipboard. So I'm going to open Excel again. And I'm going to say File, Open. And in this case, I'm going to look for all types of files. I'm going to go to my desktop. And that's the lecture SUV that I have selected. And I can see already here in the pre-screening that it's being populated. So I go Open. And now it's interesting. I have some results that are negative. I'm going to try this again. I'm going to close it. I'm going to save this probably. I'm going to close BioN, and I'm going to go again. Now open desktop, lecture,